All right, mirrors and lenses. This is kind of a cool unit and I think you'll like it. Okay, and it'll also help explain to you why things that you see are the way they are. Okay, so first we have to stop and think about light rays. Okay, we talked about them in grade 11 physics when we did light at the end of the course. But there's a couple of things that really our eye takes for granted and our brain takes for granted. Okay, light rays will travel in a straight line. Okay, travel in a straight line as long as line if. So as long as these two things are true. One is that the medium, the material, and the word medium just means the material. So the medium or the material that it's traveling through is of uniform density. So if it's traveling through water, that's clean, it'll travel in a straight line. If it's traveling through chicken noodle soup, that's not uniform. It has all different densities in there, the line won't be straight. And the second if is that if the light rays do not strike a reflecting surface. Okay? So as long as these two things are true, then light will travel in a straight line. The thing is, our eye, our brain, always assumes light travels in a straight line, at least originally, until we figure out other clues that might indicate otherwise. What I mean is, like, have you ever seen a little kid who sees themselves in the mirror? Maybe there's, and where I grew up at home, my house, there was this big, huge mirror at the bottom of the stairs. It wasn't there when I was little, but it was there when I was in high school and university, and I got my first niece from my older brother. And I can still remember the first time she saw that mirror, and it was like the wall at the bottom was a whole mirror. She put her two hands on the mirror and she kissed the baby in the mirror because she had no idea that it wasn't a real person. Cats and dogs do it all the time. They'll scratch at the base of the wall and they'll bark because they don't know it's themselves. Their eye is assuming that light travels in a straight line, and their brain hasn't developed enough to figure out, wait, that's me. I went to, when I was teaching in New York, a couple of years in, a family took the principal and I out to supper to this really nice, fancy Italian restaurant. And like really high class, like where none of us would ever be able to afford to go for real. None of us, I mean like you or me. Anyway, so when we walked, it was all, I remember it was all red. And so we were sitting at a table like here. They were really circular, I think. Carpet was red, it was red and white. And so I'm sitting here and I'm looking at the rest of the restaurant like this way. Like there's a row of tables here and here. And I'm just kind of watching while I'm listening to them all talk. And then at one point, the person at this table stood up. And when they did, the person at this table stood up. And then I realized there was a mirror right down here, and that the restaurant was really only two tables deep, even though it looked much deeper than that. And so, of course, I said to the principal, who was another nun and who was constantly astounded by my naivety as a Canadian, I was like, there's a mirror right there. This restaurant, and she's like, yeah. And I was like, oh, yeah. She said, you just realizing that? And I said, yeah. And she said, well, I'm really glad you didn't get up and go to the bathroom, because the bathroom was like here on a wall, like around a corner, which was showing up where I could see it here. So I would have like walked slap dab into the mirror. It would not have been a good way to impress these people. So our mind assumes that light's traveling in a straight line, and our brain, until we can see other things that gives us hints, like this person who stood up and then her identical twin stood up right across from her. And I was like, wait, I think there's a mirror there, because everybody in this row of tables looked just like everybody in this row. I don't know if you've ever seen, it's like Candid Camera or a show like that. A few years ago, there was one on where there was a woman in the bathroom at this like fancy hotel. And so she was standing here fixing her makeup in the mirror. And another woman came in and stood at this spot in the mirror, but she couldn't see herself. This one, her image was there. She's fixing her hair or makeup. This one couldn't see anything. And so as the show goes on, she moves like closer and closer to the other one, but she could still see nothing. She can still see nothing. And in the end, what it was these two were identical twins. And there was just a piece of glass here. And so they had mimicked each other perfectly, and it was to drive the other people coming in nuts. I think those kinds of practical jokes are wonderful. So all of that to say that our head thinks, our brain, our eye automatically assumes light travels in a straight line, unless the medium, the material it's going through is not uniform, and when that happens, it will refract. Or if it strikes a reflecting surface, and when that happens, it will reflect. And so in this unit, we're going to be looking at images formed by refraction, which will be with lenses, and reflection, which will be with mirrors. Because when the light reflects or refracts, then you're going to end up seeing an image, like seeing the object at a spot where it really isn't, which means you're seeing an image and not the true object itself. Now that image could have different sizes. It might be than the object. It'll be in a different location. It might even have a different orientation. Okay? Where the image is going to form is where the light rays coming off the object will reflect. So imagine I have just a regular old mirror, and this regular old mirror is called a plane mirror. It doesn't mean it's on like Air Canada's 747. It means it's flat and all in one plane, point line plane. So if I have an object out here, I can locate this object with two light rays. A light ray goes in and strikes the mirror straight on. It's going to reflect straight back, but if I follow it back, I'll get a line back here. Now imagine another light ray comes and it strikes the object and hits the mirror like this. It's going to reflect straight off like this. In grade 11 physics, we learn that the angle of reflection is always equal to the angle that's coming in on. This one's called the incident angle, if you remember. And this one's called the reflected angle. And the law of reflection just says these two angles are equal. Theta I equals theta R. So to find the image, then you just follow the reflected ray back, and where the two reflected rays cross, that's where your image will be. Where they cross or where they appear to cross. In this case, they're appearing to cross because they're not really making it back there. Okay, so you can always find the image by where the rays cross or appear to cross. Okay, so having said that, there's actually two different types of images we can get. We can get real images or virtual images. Okay, for a real image, the characteristic number one, and we're going to run out of time before we get through all these. Characteristic number one for a real image is that light from a common point, so like these two rays from a common point, pass through or are reflected by an optical device that causes them to converge and intersect. So light rays from a common point, you should be writing it down too, pass through, if it's a lens, or are reflected by, if it's a mirror, an optical device, meaning a lens or a mirror. So pass through or are reflected by an optical device, like a lens or a mirror, that causes them to converge. To converge, to come together, to intersect. So to converge and intersect. Converge